We started with geothermal. We saw no improvements whatsoever to our utility bills here. In fact, if anything, they kind of went higher because the geothermal was cycling. And what the problem was is this house was just leaking. Like it was leaking like a sieve. When we had an energy audit did, all you need to know is the number. We had a number come in at 260%. And ideally, you want to be around 130% or lower. So everything that we've done here, we've literally improved our number from 260 to 120. Wow. Okay, not easy to do in a home that was built that long ago. You know, that's so long ago. So I'm going to start kind of work our way this way, show you some of the improvements that we've made. We are on a well here, so obviously, like anybody else who's on a well, water conservation is important. We have installed, this is the most heavily used toilet in the building. We've installed a dual flush toilet. So literally this uses about 0.8 liters of water for a single flush for number 1 and a typical 1.6 liter flush for number 2. So most of your flushes are 0.8 liter. We've installed in every bathroom fans and dimmer switches on all the lights are on dimmer switches, but here we put on a fan because you may be meeting with a client and they've had to come in on an emergency basis or whatever, and they're a little embarrassed and they leave and they turn the fan on, and nobody, they're the last client of the night, and you come back the next morning and the fan's still running. So we've got all these fans on timers. Same for bathrooms where you've got maybe a small bathroom and you've got showers with a lot of moisture. The fan will go on, but you don't have to worry about leaving the fan on forever. An energy audit essentially looks at the house and says, what do you need to seal up so that you're no longer heating the outdoors or cooling the outdoors?
The whole idea of this system is, part of the atmosphere we're living in is it was created that air always has to exist in all places, and so what the thing is we do is we're blowing the air out, and so it has to be replaced by something, and so air has to get back into this house somehow, and so it's going to come in the area of least resistance. And so if there's an open window, it's coming through an open window. If there's a tiny little hole from maybe a screw that was pulled out or something like that, it's coming through that. So the idea is we're trying to find air leaks in the house by blowing the existing air in this house out, and so it becomes a cycle. And so by doing this, I'm able to go around with an infrared camera, which I'll show you, or just the back of your hand, and just go like this and find places. You'll find, especially with, now this is a masonry house, which is built with brick. That was it, brick on the outside. Actually, horsehair and plaster was the mortar that they used. But on the frame wall, what you can do is almost just go at every light socket, and you'll be able to feel air pulling through the light socket. With this device, this is a manometer. Based on the size of the house, the floors, the square footage, essentially the cubic feet of the house, of space inside of your house, and the location, we put together a baseline building airflow standard. So there's a number for each individual home. No home is really alike. And with that number, we will try to find the number that comes up here at 50 pascals would indicate the amount of air leaks you have. And so what will happen is this manometer, I'll turn it on and then set it at what is CFM 50. CFM is cubic feet per minute at 50 pascals. Or what we're going to measure is the cubic feet per minute that we're blowing out at a rate at 50 pascals. And so I set the baseline, which is just something we have to do with this tool. Alright, how did that work? Now the chances are, I'm going to come take a look at these numbers real quick. This number here we want to achieve up to 50. Now chances are there's a door open in this house since people are walking in and out. And so that number is not going to be able to be achieved even if I turn this up so high because so much air is pulling through the air. Now if they shut that, we'll probably be able to get close. This number here is cubic feet per minute that we're losing. That's going through that fan. And
this house should be around 5,500. Now, if we get this thing set up, it'll probably read about 6,700. Like I said, because all the main doors are open, or at least it's only the storm doors that are shut, so we're getting a lot of air flowing through there. But the idea with this is that you'll be able to go around there, feel air leaks. I'll turn this up, and we'll go by that door. We'll just that air that's coming through that side of the house and going outside that fan.
Oh, wow.
Because like I said, air has to replace this. You do the same thing anywhere in the house. Now, for most homes, they're at a size where you can kind of just walk around your house, look, find out where the air leakages are, by running your hand across it, looking, around windows or something. Now the next tool I'll show you, which really helps with this, is this infrared camera. This picks up heat or temperature differences. Actually, it does pick up just heat. So you can see in this room, the walls are a little bit a little bit cooler than the people. So here you see on the left, on your right-hand side, is the hottest point in this photo and the coldest point in this photo. So the warmest point in this photo is the white on your faces that are in this photo. The coldest part is behind you, just on the wood and the stone wall. Now, the nice thing with this is another rule of nature, if you will, is heat always goes to cold places. Heat always goes to places where it's less cold. Okay, it happens everywhere. So in the winter, you're trying to heat your house, your heat's doing the best it can, it wants to get out. It wants to get outside. In the summer, you're trying to cool your house, the heat on the outside is doing the best it can to get inside. So on this chair right here, let's see that right here, that chair right there is about 74 degrees if it's the warmest spot in this photo. The heat on my hand, if I just rub it against this chair, because that heat on my hand wants to get on this chair. Because heat's going to cold. As you can see, there's my thumbprint on that. And if you just put your hand on the table, you'll be able to see, there's my handprint. They use this for forensics. If you guys are interested in those TV shows, CSI or whatever, this is the kind of thing that they use. We use it to find air leaks. Insulation problems is another big thing with this. See, that thing will show you what the air leaks are, but it won't tell you if you have insulation problems. This, on most stud-framed houses, I'll be able to go in and just shoot the wall, and you'll be able to see every 16 inches for most homes, you'll be able to see the studs, because heat will conduct through that wood. Just that piece of drywall that is on the outside of that wood won't show up, or won't be able to block the heat. There's not enough insulation to block the heat from picking it up. So this is a big help for us on any type of home energy audit that we perform, or any type of home new home we build, or any type of renovations we make, so that we can try to fix any of those problems, especially in the lines of air or insulation issues. This thing will also pick up, I've neglected to mention this about 4 times, Charles hit it every time, moisture issues. So if you have moisture problems up in the house, whatever it may be, if water's getting into your house, which essentially causes mold, this guy's going to pick it up. If you had, if this floor, if I sprinkle water on this carpet, you wouldn't be able to see it. But if I use this camera, you would be able to see just those droplets of water that have been on this carpet.
You may have something going on behind your walls that you're not even aware of, and that would help us show that.
And they show up as a heat source, or cold? Do they show up as like water? Does it show up as a heat source?
Usually cooler, because actually my sister, she went running yesterday, and I was standing here with it, and she came in, and she was about 5 degrees cooler than me. I thought, that's kind of weird, because I thought your body heat, but with sweat, actually cooled your body. And so that's what it picked up. It picked up the cooler air. Of course, it was kind of cool yesterday as well. So it will show up as cooler. Actually, we were in a huge, massive auditorium, and there was an air leak in a HVAC duct just from the moisture. And I mean, you couldn't you could hardly even see it from the blind's eye, but this guy took a camera and he said, see that spot right there? He goes, there's moisture leak. I looked at it, I was like, you know, this shit right. Because it was just a massive warehouse. So this thing will pick up any type of, moisture leak, condensation, insulation, or air problems.
This is your typical attic. In the summertime, this reached 140 degrees up here. And in the wintertime, it was the outdoor temperature. It was 10 degrees. This is closed cell foam insulation. There's two types of foam insulation. There's open cell and closed cell. This happens to be closed. It's very rigid, adds a lot of structural support to the roof system here. We have a metal roof on the other side of this. Open cell is very different, has no memory. You can put your hand, your thumbprint through it, and you're going to see 5 finger holes. Okay. This has tremendous, both of them have very good insulating value. This one's got a little bit better than the open cell. This has about 6.5 R value per inch. And we have about 5 inches of insulation here blown in. So this has an R value of approximately 30. And then most folks, if it's done up in their attic, they've also got insulation on their floor. But what this stops a thermal gain in the summertime. So this attic is essentially, we were about 5 degrees difference between what you felt on the first floor and what you now feel here in the attic. It's made probably the biggest difference in the utilities in this house than any other singular thing we did. For those who heard the story, we installed geothermal and we saw no real improvements to our utility cost here. And then we went through the energy audit where we pressurized the house, we saw where the leaks were, and then we went about closing them. This was the primary culprit. It's the primary culprit for most homes. It's not windows like some would have you believe. It's primarily the stack effect you get with hot air rising. And so you can see here, we've got ductwork in here. Now, in my own home, I live on the other side of Frederick near Spring Ridge. Tuesday, I'm having this done to my house. And I'm having it done because I actually have a heat pump in my attic. And when it's 140 degrees in that attic, it's trying to cool my second floor in a 140 degree environment. Same in the wintertime. When it's 10 degrees in that attic, it's trying to heat my house in 10 degree temperature. It's one of those things that if you're thinking about doing it, there's a tax credit right now that's applicable. It's 30% on the material cost. So in my case, the material cost to do my attic are $2,600. I'm going to get $780 back on my taxes. So it brings the total cost to do the project to about $2,000. That tax credit expires this year. We would, whether we're building a new home, if we're building a new home, it's easier. We can make a house very tight now by using the SIPS panel. I think Peter probably showed that to you. That's the basically the foam that we apply to the outside of the home, and then we do this to the attic. An Energy Star built home, and we build all of our homes minimally to an Energy Star rating, which is only 15% more efficient than what a code built home is. The last we built, just finished it about 3 months ago, the first ever gold certified home in Frederick County, and that came with a Energy Star rating of 54. It was almost 50% more efficient than what a code built home will allow you to do.